minute. But I haven't got any notification from you.
Okay, and this meeting, continue. It doesn't say anything. It just, when I press on record, it says, please ask the host to give you permission to record. Maybe you have to do this before you create the session.
I don't think so, but I have just kept the session on recording. I will be sending you right after the class.
Okay.
I'll email you. So this was the rule. If n can be any number, like 1, 2, 3, 4, any integer. So what this rule says, this power will come down, power, and then -1 from the power, and d over dx of this. The derivative of a function with itself will always be 1. Just keep this in, just note it down somewhere, or just keep it in head. The derivative of a function with itself will always be 1, like d over dy with respect to y will always be 1. There's an d over dz. If we derivate it with respect to z, then it will always be 1.
Okay, so any derivative to a constant will be 0. Then any derivative to itself will be 1.
Will be 1. And there's a power rule, which is there's any power. For example, there is x square. We have to find the derivative of x square. We have taken n equals to 2. So what the rule says, we have to take n, that is the power, out. Then we have to take x, then as it is, and then we have to -1 from the power. So 2 minus 1. And then we have to take the derivative of x. So the derivative will be 2x, 2 minus 1 is 1. We don't need to write. And the derivative of a function with itself is of 1. So the derivative of a function is 2x. Is it clear?
Yeah, okay, so 2x, we don't need to put the 2 because it's already, you don't need to put the -1 because it's already, it's -1. So, and then how did we get to 2x?
Which x?
The last one, the one with the circle. How did you get there?
Oh, this one.
No, the whole thing.
Okay, let me just erase it down and tell you. This 2 comes down here, and then this x as yes, x 2 minus 1 is 1, and the derivative of itself a function is 1. So it will be x power 1 is 1 x.
Yeah. Okay, understood.
Let's do another one. Like if someone asks us to find the derivative of x raised to the power 5, then what will we do?
Can I do this one?
Yeah, sure.
Okay, so it will be 5x. Okay. And then where do we get the 2 above the second one, the first one?
You have to use this. There's this formula.
Okay.
Have you noted the formula?
Yeah, I have it noted down.
Okay,
so it will be 5x and then 5 to the power of -1.
And then?
Okay, and then we do the derivative over itself, like 5x.
Derivative of a function itself, because it's x here.
Okay, and then it will become 5x, 5, just like that.
It will be 5 here.
No, 2, 1. There will be nothing over the x, and then we can put a bracket to 1. Yes.
On this x, on this x.
Yeah.
It will be 4, right? Because 5 minus 1 is 4.
Okay. Understood.
Okay, can you do now for x7? It's just that if we do it in the class, then you just keep these rules in your head, because these are very easy rules if you keep on practicing them.
Yeah, okay. So this will be 7x to the power of 6. No, initially it will be 7x. Yeah, okay, 7x to the power of 6, and then put a bracket for 1, because it will be equal to 1.
So the derivative is 7x6.
Yeah.
Okay, so let's move on to our third rule. Let's move back to the book. So they have just done the examples like x square. They have find the derivative of an x square. They found the derivative of x square is 2x, and they did for x3, and they got 3x squared. Is this point clear to you?
Yeah, this is
okay.
clear. Yes.
Okay. So this was a power rule, and they have just put the rule in the box. So that's what we have written down.
Okay, clear.
Then moving further, these are just examples. Like if someone asks us to find the derivative of x6, it will be 6x5, right? Using a power rule.
Yeah.
And then what will be for y equals to x raised to the power 1000? What will be its
Just
derivative?
-1. Yeah, 1000. Put it down. X -1.
Yeah, and same goes with part C. 4 down and 4 minus 1 in the power, so it's 43.
It will
And so
become 3.
yeah, and so same goes with part D.
Yeah.
Okay, and if we have something like this, x raised to the power -1. Here we had a positive power. Now we have a negative power. What will we do with it? Let's try to understand it. This is the same rule. Same power.
Okay. Okay. I can't hear you properly.
Can you hear me now?
Yeah, but sometimes your voice goes and then comes back.
Yeah, I've just ordered the new headphones, and I will be getting them like in 1 or 2 days probably.
Hopefully, yeah.
I'm sorry for the inconvenience.
No problem.
So if so far we had the positive power like x square, x5, x6, we were doing with a positive power. Now, if someone asks us to find the derivative of x minus 2, x minus 1, or something with a negative power, what we'll be doing, we'll be using the same rule. So d over dx of x minus 1, let's start with it. So the rule was the power first, power is -1, right?
Yes.
And then 1 from the power, so -1 from the power, and then taking the derivative of a base, that is base x.
So it's the same thing.
Yeah, this is the same thing. If some,
okay,
it can be asked like this, 1 over x, the same thing. It can be asked like this, 1 over x square. So you know that it's x minus 2. Is this clear?
I don't understand the 1 over x part.
Like if x minus 1 is equivalent to 1 over x, because we are taking, yeah, so if someone asks us to find the derivative of 1 over x, it's equivalent to x minus 1, then we calculate the derivative of x minus 1 or 1 over x using the same power rule, like power first and then taking the -1 from the power and then taking its derivative. So -1 and x minus 2. Can we write this like this? -1 in the numerator, and we make it a positive power by bringing it in the denominator, like x squared.
X square.
Yeah.
Yeah, it's the same thing.
Yeah.
Okay.
So
but then the first answer, will it be enough?
It's better to write in this form.
Okay.
Like you should have an idea of both the forms. So whichever way is acceptable.
No, sure thing.
Can you do for this one? X minus 4. Can you find out the derivative of x minus 4?
Okay, so it's gonna be -4x. Yeah, and then the power will do -1 also, so it become -5.
Which will be like this.
Yeah, and then this the same one of this we can do as -4 over x to the power of 5.
Yes.
Good.
So let's move on to the book. I mean, it will be the next rule, I think. These are just the example. They have find out the derivative of 1 over x square. So it will be x minus 2. So they just calculate its derivative. If something is like this, like 3 and then square root of x square, how will be doing it? Let's do this question, part B. Okay, so how will be finding out its derivative? Can we write this function as x square and by 1 over 3?
I don't know, to be honest.
Let's if we remove the cube root, this part, because there's a cube, there will be x square as it is and 1 over 3 for removing this square root.
For removing the cube, yeah.
Yeah, so it will be 1 over 3. So
Okay.
can we write it like this? 2 over 3 multiplying 2 with whole the power 1 over 3. So it will be 2 over 3, right?
Yeah.
So is it easy for us now to find the derivative of x raised to the power 2 by 3?
Yes, we can do the same way as we did earlier.
Yes, using the power.
Hmm.
So power
So
first.
this will be the power first, and then x, and then we do -1 from the power. Okay. And then that's all.
Yeah.
We can.
Just keep this in mind that we also derivate, because we don't need to write one as we are practicing. It's if we are practicing, then it's necessary, or to just have a good practice, just to write that we also derivate the function itself, because write when other variable, so we need to derivate it as well. Then the answer will not be one. So if we are just practicing or learning stuff, then it's necessary that we write that we also derivate the function of itself. Just for the practice. So 2 over 3 x, and if we solve it, it will be
-1 over 3.
Yeah. So 2 over 3
Yes.
x minus 1 over 3. And if we convert it into the positive coefficient, so it will be 2 over 3 x1 by 3. Is it clear?
2 over 3 x. What's the one on the bottom?
This we just wrote. It was a negative coefficient. We just broke into numerator. I mean the denominator, so it will be positive x1 by 3, x power
Okay.
1 by 3.
Okay.
Let's back to the book. They have just written the answer as a positive, negative coefficient. We will be coming back to the question, example 3 later, because it's asking for the tangent line and normal line. I've actually explaining you how we calculate it. So just keep focusing on the rules now. Okay, the third rule is the constant multiple rule. If we have a question something like this, 3x, then 3 multiplied with x. 3 is a constant, x is a variable, right? So in this rule, constant from f of x can be like any function, x squared, it can be x squared, it can be x cubed, it can be any function. So to calculate,
can you repeat, please, because your voice wasn't clear?
Okay, sorry. Now the third rule is the constant multiple rule, and this is the rule that we will be using to calculate the differentiation of any function multiplied with a constant. So c is a constant term and f of x is a function. So c can be like any constant term, 1 2 3 4 5, any constant term, and f of x can be like x squared, x cubed, any function in terms of x. So what we'll be doing, we will be keeping or taking whatever the constant term outside, and we'll be taking the derivative of a function only. Okay, let's understand this. I mean this rule using some rules. Constant multiple rule. Let me just write it down. Third rule is constant multiple rule. It is d over dx, c f of x, taking c outside, it will be d over dx f of x. C can be a constant. F of x can be any function. So
For me, sometimes I get confused with the terms. Okay, constant, I know is constant is any number, right? Okay, and then what just because I get confused, what's a function?
1 minute. Any number function is like in terms of x, it can be x square, it can be x cube, it can be 5x, it can't be 5x square, it can be x7,
So
any
any
function
x,
yeah, any function in terms of x, only x.
so any x with a power, so it cannot be 5x or 2x, it has to be a power, right?
No, 5x can also be a function. I mean x also can be a function.
Okay,
and then
okay,
and then 5 isn't, then 5 isn't a constant term.
Okay, understood.
So the rule is that we take the constant term out and we derivate only the function. The function will always be like in terms of x, then that you will get an idea that this is the function, this is the constant. For example, if someone asks us to find the derivative of 3x squared, what we'll be doing, we'll be taking 3 out because it's in constant term, and we just derivate the x square. We can use again the power rule to calculate the derivative of x square, right?
Yeah, it will be x squared.
So
It will be. So you said the constant, we leave it outside. So inside the bracket, it will be 2x, 1.
Yeah, 2x multiplied with 1.
The power of 1.
So it will be 6x.
Okay, understood, yeah.
Okay.
So this is the derivative of the function up, d over dx, bracket 3x squared.
This was the function
Okay.
here. And we took
And then the answer is 6x.
Yes, the derivative of 3x squared is 6x.
And then what's the question here? Find the derivative of 3x?
The question will be asked you that find the derivative of 3x squared. Find the derivative of this function. So it will be like this.
Okay. Because for me, math is a very hard subject. Like physics and math are similar, but physics I can understand, but math I cannot.
I like math calculus one is great. You will be getting like very
again
that.
Hopefully.
Yeah, hopefully. G over gx, and can you find out the derivative of 5x 4?
Okay, so initially we write 5 and then we put a bracket. 5 is outside. It will become 4x to the power of 3.
Okay.
Yeah, I mean, yeah, this one. Okay, and then we multiply by, it will become 20x3, x to the power of 3.
Yes.
Okay, good.
So now this rule I think is clear to you. Let's move on to the next rule. In the example 4, they have done the same thing. They just calculate the derivative of 3x4, putting the 3 outside and finding the derivative of x4, which is 12x. Is it clear that how they have got 12x3?
Yeah, it's clear.
Okay, and then they did for -1. Okay, let's do this one. D over dx.
D over dx, this is just part of the question, right? Nothing important for us.
Yeah, this is the derivative. Like if someone asks the 5, find out the derivative, find the derivative of, I'm just writing it quickly, derivative of -1. So you know that this is the symbol that we use for derivative.
Okay, understood, yeah.
symbol for derivative. And then we write whatever the function is. The function is minus x. So if we don't write, like, we can take the minus sign out, because for us it is in a constant term. Like if it's not mentioned, then it's minus 1 times 1. So taking minus 1 out and taking the derivative of x with itself, it's 1. So the answer will be 1. Oh, I mean the minus 1. Is it clear?
Okay. Clear, yeah.
So back to the book. Then we have another rule that is called the sum rule, where if we have asked the two functions, like the function f of x and the function g of x, there are basically two functions that are given to us and they are added together. How we can find out
can you repeat, please, because your voice is not clear?
Yeah, sure. So here we have a sum rule. Is it clear now?
Yeah, your voice is not clear.
Is it better now?
Yeah.
Okay. So we have a sum rule, g over dx, f of x plus g of x. So these are the both functions, f of x and g of x. These both are the functions, and if the functions are added together, how we will be finding its derivative? So what we'll be doing, we will be differentiate them individually. Like we will be derivating d of f of x plus, and then we will be taking derivative of g of x separately. For example,
Okay.
some rule. Let's just back to the screen. F of x plus g of x. F of x is a function number 1, and this is the function number 2. Both are added together, and if someone asks us to find the derivative, so what we'll be doing, we will be individually finding their derivative. So we'll be taking the derivative of f of x, then we have a plus sign in between, we'll be writing the plus sign, and then g over d of x of g of x. This is the formula, or this is the rule that we'll be using to calculate the derivative of a function when they are added together.
So the same thing, we just expanded.
Yes.
Okay.
So so far we were studying the functions. So far we were studying for one function, like 5x4, it was one function. If we added 2x3 plus 2x3 with the 5x4, then there will be two functions, right?
Yeah.
So if we have 12x3 plus 7x minus 2, these two are functions.
Yes.
And someone asks us to find their derivative. So we will
okay,
be doing.
So can I try?
Yeah, sure.
Okay, so for the first one, it will become so the 12 will be left alone, and then it will become 3x to the power of 3x squared.
So it will be x cube, and then it will be 12 3x squared, right?
Yes. Okay. And then for the second one, it will be 7x.
It will be like this, but like taking the 7 out and then taking the derivative of a function.
Yes.
Okay. And then tell me the derivative of x minus 2.
It will become x to the power of 1 over 2, correct?
Sorry?
Will it be x to the power of 1 over 2 to get rid of the minus?
We take the power out and then we add minus 1 to the power. So it will be minus 2x minus 3. Isn't so?
Okay, I got confused. Okay, yes, I got confused. Okay.
So minus 2 over x cube. Right?
Yes.
Okay. So 3 times 12 is 36. x square plus minus is minus. 7 times 2 is 14 over x cube. This is the answer. Is it clear?
Yes, clear.
Okay, let's do one more example that you have to do this. Tell me what should I write? Derivative of, there can be more than two functions, right? The rule will be the same.
Mm.
So let's do for 12 x minus 5 plus 3x minus 2, 7x square. Can you find the
It can be
derivative?
also, can it be plus minus like in the function?
Yes, it can be. Like it can be like there can be minus sign as well. So added or the rule for sum and subtraction rule will be the same.
It's the same. Okay.
Yeah. So this is the plus sign for now here, plus 7x
Hmm.
square. So can you please tell me what should I write?
Okay, so so the first one will be before the dx there will be 12.
Okay. You mean here?
Yeah. Okay, and then it will become x to the power of minus 5. Okay, and then the second one will be the same, 3d over dx to the x to the power of minus 2.
Yes.
And then the same on the last one.
Plus 7, right? And then
Yes, plus
derivative of
7.
x square. Okay.
Okay, and then now 12 to the power of negative 5x to the power of negative 6.
So 12, I wrote down 12. And then what
negative 5.
Okay.
X to the power of negative 6.
Yes.
Okay, and then the same here, 2x. No, negative 2x to the power of just negative 2x. And
Negative
then
2
here,
and what should be the power of x?
no power.
Why?
No, negative 3. Sorry. Yeah, negative 3. And then again here, 7 to the power of 2x negative 3. No, 2x negative 1. Just x.
You mean like this?
No, just 1 because it's 2.
Yeah. So it will be minus 60 over x6, right? And minus 6 over x cube and 14x.
Yes. And then just this is the answer, or do we have to do anything extra?
No, this is the answer. We don't need to simplify it further.
What if the powers of negative 60 and negative 6 were the same? Like let's say both of them were x cubed. Should we do something here?
Let me just write down your question here. What you have asked?
Okay, so negative 60.
Negative 60.
Over x cube.
Over x cube.
Okay, minus 6 over x cube also.
Okay.
So should we do something here?
Yeah, both the functions are with the same power. We can add them or subtract them, right? So we can do it something like 60 and taking it like x minus cube minus 6 x minus cube. We can write it like this. Right? So both have the same power, then we can add them. Minus 60 minus 6 is minus 66 x cube. It would be like this. Instead of finding the derivative, separately, we can, if their power is same, then we can add them. So it will be minus 66 x cube or x raised to the power minus 3 and then d over dx of minus 66 over x cube. We can do it like this. Is it clear?
Understood, yes.
Okay, moving to the book again.
When the professor was teaching this last semester, it seemed, I don't know, but his like even the other students, they said that it wasn't clear.
Oh.
But now it seems easy.
Yeah, it is actually easy. The calculus one is nothing. You'll be getting like in 2 weeks we'll be like going most of the basics, and then we can move to the calculus.
Okay.
This is again the same rule that they proved it, so we don't need to further how they have done it.
Again, please, your voice is not clear.
This is just the proof that how they got the formula, so we don't need to go through it. Let's just skip it. This is the most important rule, the differentiation rule. This rule is like most of the time used rule in the differentiation. We need to understand it very. Oh, this is the difference rule. Sorry. Like the same sum rule, we were just adding them and then we are subtracting them. This is the same rule.
Okay, so it's the same thing.
Yeah. So just write. Do I need to write it down here?
No, we covered it already. You can just put the question.
Okay. So this is again the same rule, and here the question is that with a plus sign, minus sign, can you note down this question and do it yourself? Example number 5.
Okay.
Have you noted out the question?
Yeah, I wrote it. So in this case, the derivative of negative 6x is just 6, right?
Yes.
Okay. And then what about the derivative of a constant? It will be 1. No, 0.
Yes.
Okay.
This question actually covers all the rules that we have studied so far.
Okay, so I got 8x to the power of 7 plus 60 to x to the power of 4 negative 16 x cube plus 30x square minus 6 plus 0. So just minus 6.
Yeah.
Yeah, correct.
Yeah. So moving to the question number 6. It is. This is actually a simple question, but we need to understand what it is asking. So find the point on the curve y equals to x4 minus 6x squared plus 4, where the tangent line is horizontal. Okay, so we have given this function. I mean, the curve graph for this function is given to us in the figure number 4. And it's asking that we have to find a point on the curve where the tangent line is horizontal. You know what is tangent line?
No, I was going to ask you now.
Okay, so let me just go back there.
There is a tangent line and there's also another type of line, right?
There is a tangent line, another line is?
Is there any other type of line or just tangent line?
There is also a normal line. I will be keep explaining you if there is terminologies come, like in the previous question I just skipped it. It was covering tangent and normal line both. So we will be
Okay.
doing probably today or tomorrow that question.
Okay.
So if this is the curve, okay, and someone asked me to find a tangent line, horizontal tangent line. These lines are the horizontal because they are parallel to the x-axis, and these lines are the vertical lines. These are the horizontal, and these are the vertical lines. So it was asking us to line should be like this anywhere on the curve. So this is the tangent line is which touches the curve at only one point. It won't be like that it keeps on touching the curve all over the points. It will be touching the point, or it will be touching the curve at only one point. Like this is the point that will touch the curve. This is the point where it will be touching the curve only once. This is the point where the tangent line will be touching the curve. And these lines are the horizontal tangent line because they are parallel to the x-axis, right?
Understood, yes.
If the curve is something like this, okay, so the tangent lines will be touching here at this point. So, but they are not horizontal tangent lines. They are vertical tangent lines. So,
understood.
So moving back to the question. Okay, where the horizontal tangent line is horizontal, so we know what it means, and we just need to find out the points. Points like we have to find its x coordinate and we have to find its y coordinate, right?
Yes.
So x4 minus 6x square. Let me just write down this question. Y equals to x4 minus 6x square plus 2. So there are 2 classes of calculus 2 in a week, right?
Just a second. Yes, 2 classes. No, 3 classes. Tuesday, Thursday, and Sunday.
Okay, and after 2 hours or maybe 2 hours, right?
No, each class is 50 minutes.
Okay. So find the point on the curves, on the curve where tangent line is horizontal. So to find out, if this is the curve, these 3 are the points where tangent line is horizontal, but tangent line is touching the curve. We need to find its points. That's what it is asked us to in the question. Okay, so we know one point that is really important to remember, that the slope of a horizontal line will always be 0. Will always be 0. This line.
Okay, so slope of horizontal line will always be 0.
Will always be 0.
Okay.
And another point similar to it, slope of a vertical line, vertical line slope will always be infinity. You know what is slope? Why it's infinity and why it's 0? Slope is a tilt, like a ladder. That this is a ladder. Okay, that it is
slope.
tilt.
I know.
Okay, so we actually don't need to explain it, right?
But infinity and 0, I don't know.
Okay. When it is parallel to the horizontal line, it is like flat. There's no tilt, right? There's no tilt. It is just parallel to the x-axis. So if there's no tilt, then its slope will be 0, right?
Yeah.
And if it is at 90 degree, okay, there's an, if this is a 90 degree angle, and it's a vertical line, the tilt is like the tilt is at maximum. So it is,
So it'll be 1.
so sorry,
It will be 1.
Of degree 90. If the tilt is like its maximum, then it is, so we define it as an infinity. Because if
Okay.
if it is in a vertical line, then it's hard to climb at. So its tilt is at infinity, its slope is infinity. So these 2 points are like you will be needed in further questions.
Okay.
So the question was that points, we have to find the points, and whether horizontal tangent is horizontal, we can find by finding its slope. The derivative, the third point, is the derivative of a function will be equals to slope. These 3 points you have to just keep in your head, that the derivative of any function like x square, x cube, any function will always be equals to slope. So if we calculate the derivative of a given function, then we will be finding its derivative, or then we are calculating its slope, right? And the slope of horizontal line is 0. So we can equate our derivative function equals to 0 and then find the value of x. Let's do it first. So slope equals to d over dx of a function. Our function is y. So y of x. So it will be d over dx, and our y of x is x raised to the power 4 minus 6x squared plus 2. If we, what would be the derivative of x4?
4x to the power of cube. 4x cube.
And what about minus 6x squared?
It will be 12x.
And then the constant will be
0.
0. So, and we know that they just mentioned in the question that it's a horizontal tangent line, right?
Yes, horizontal. So it will be 0.
So its slope will be 0. So we can equate.
Slope will be 0.
So we can equate our function as slope 0, right? Okay. Now we can factorize it. So can we take 4x common?
Yeah, because both are 4 into 4.
Yes. So it will be x square minus 3.
3. Yeah.
So, and there's a 0 as well. So
I'm a little bit weak with the factorizing.
Sorry?
Factorizing, I'm a little bit weak in it. This one I understand, but then some maybe harder types, I will not. Maybe I will get stuck.
Okay.
This one is easy for me.
Yeah, we'll be doing it. So 4x equals to 0. And can we equate it 4x equals to 0 and then x square minus 3 equals to 0?
Don't know.
Like
yeah, because 2 points.
Yeah, because we have two functions separately. So
Yeah.
both the functions are equals to 0. If one function is 0, it makes other function is 0. The answer is 0, right?
Yeah.
So if this is 0, it will make a whole function 0. We can equate both the equals to 0.
Okay.
Okay. So dividing both sides by 4, we'll be getting x equals to 0. This is the one value of x, which is 0. Right?
Yeah.
And then we have x square equals to 3. And taking the square root, it will be x equals to plus minus square root 3.
Yes.
So these 3 values that we have got. Okay. And we know that our tangent curve is intersecting, or touching the curve at 3 points. So these are the 3 points. And let's just find out if they have asked us to find
But
out.
here there are only 2 points.
There are 3 points. One is x equals to 0, and one is plus square root 3, and one
Plus
is
and minus are separate. Okay.
Okay, yeah. Back to the book, 1 minute. So x equals to plus minus square root 3, and yeah, x equals to 0. So
Okay.
so far what we have done this, and then what they have done, yeah, they have find out its y coordinates. So for the y coordinate, we will be putting the value of x, putting x equals to 0, square root 3 into original function. Original means the given function is x4 minus 6x square plus 2. Yes. So have we made a mistake somewhere? Because we are getting 0, 2. Oh, we wrote our function as x4 minus 6x squared plus 2, and the original, in the example it was 4. In the
But then for this one is right?
Yeah, I just wrote the question wrong because the question actually was with plus 4. It was just
as long as we did right.
Yeah, it was actually our understanding. So
Okay.
So putting x equals to 0 into the function, it will be 0, 0 and plus 2, right? So our value is y, y is 2. If we write in the points form, so x is 0 and y is 2. This is the first point there where our curve is touching. And for the other points which we have got as x value, we just put these values into the formula in the the original function. So y equals to putting x square root 3, 6 square root 3 square plus 2. So it will be 9. I think 1 minute. Yes, it is 9. Because we can write it like this: 3 raised to the power 1 by 2, and then whole is multiplied by 4. So it is 9 minus. Is it making sense to you what I'm doing?
Where did you get the 9 from?
Okay. Because we had square root 3 raised to the power 4, right? So can we write square root 3 as 3 raised to the power 1 by 2? Because if we remove the square root, it will be 1 over 2.
Yeah,
right?
yeah.
Whole power of 4.
If we remove the squares, it will become to the power of 2, right?
Yeah, if we remove the square root,
it will come to the power of square.
Yeah. And then 2 times 4, 2 goes into 4 by 2 times. So it will be left with 3 square, which is 9. That's this is why we have.
Yeah, okay.
Okay. Again, we have square root 3 times 2. So 3 raised to the power half, whole power of 2, right? 2 is cancelled out with 2, and we are left with 2 only. Is it clear?
Yes.
6 times 3 is 18 plus 2, and then y equals to 9 minus 18 is minus 9 plus 2, and y is minus 7. So our point is x comma y equals to x is root 3 comma minus 7. And again we have to do for y equals to minus 3, and need to find out x and y coordinate of another tangent. I mean another
Yeah,
point.
it's the same thing.
Yeah, it's the same.
Yeah, understood.
Yeah, and the question that were asking us, the 3 points were really important to remember.
Understood,
Yeah,
yes.
yeah, these the question, and these 3 points are really important. You just keep these 3 points in your head. That
Okay.
I think time is up. No.
Okay.
Okay.
So tomorrow at the same time?
Yes, tomorrow at the same time.
Okay, no problem. If there's anything, I'll let you know.
Okay, and we can do the payment like on Sunday or Saturday, like weekly.
Okay, no problem. So I'll Sunday. Okay, and also I'll the $10 for the quiz. Okay.
Yeah, so we can do like on Sundays, every Sunday.
Okay.
Okay.
Tamam.
Okay.
Thank
Thank
you.
you.
See you
Bye.
tomorrow.
Yeah. Bye.
How will you send me the recording?
I think it is 1 hour session, so probably I can send it to you via email.
Okay, can I give you my email, please?
Yeah, sure. Can you just WhatsApp me?
Yeah, of course. Okay.
Okay.
Thank you.
Thank you.
Bye-bye.